This is the last chapter, Electrochemistry. Electrochemistry is the branch of chemistry in which we study interconversion of electrical energy and chemical energy. In some cases, electrical energy change into chemical energy, like electrolysis of any solute. For example, electrolysis of sodium chloride, chlorine gas is formed. And nitrogen gas is also formed. So this is, and the chemicals are produced, so it is the change of electrical energy into chemical energy. While in dry cell, chemicals are used, so chemical energy produces electricity. Means chemical energy produces convert into electrical energy. Now for electrolysis, what is electrolysis? The process in which when the solute is dissolved, it is split into ions and conduct electricity. It splits into ions. For example, sodium chloride break up into sodium ion and chloride ion. So sodium is cation and chloride is anion. Cation is that which is positive, having positive charge, like Na positive is cation and Cl negative is anion. There are two electrodes used in electrolysis in the container. They are called electrode and anode and cathode. Anode is positively charged and anions, that is negative charge ions, goes to anode because it is oppositely charged, while cation, positive ions, goes to cathode and cathode is negatively charged. At anode, oxidation occur and at cathode, reduction occur. What is oxidation and reduction? So now we are starting this oxidation and reduction definition as well as explanation. Oxidation is the gain of oxygen, addition of oxygen, and reduction is the loss of oxygen or removal of oxygen. For example, in the extraction of iron from its ore, iron ore, like Fe2O3 plus 3CO, 3 carbon monoxide, form iron and carbon dioxide. This is by mistake, it is cutted, but this is CO2. So CO change into CO2 means addition of oxygen, so this is oxidation. While in Fe2O3 change into Fe, that is removal of oxygen, so this is reduction. Because both oxidation and reduction are occurring simultaneously, this is known as redox reaction. Redox, RED for reduction and OX for oxidation. Then the other definition for oxidation and reduction with respect to hydrogen transfer. Addition of hydrogen in reduction and removal of hydrogen in oxidation occur. Both reactions occur simultaneously. Notice that these are exactly the opposite of the oxygen definition. Oxygen definition, addition of oxygen in oxidation, while removal of oxygen in reduction. So removal of oxygen and addition of hydrogen in reduction. In oxidation, addition of oxygen and while removal of hydrogen or loss of hydrogen occur. The example. For example, ethanol can be oxidized to ethanol, CH3, CH2OH. This is ethyl alcohol or ethanol. Change into CH3, CHO means hydrogens are removed. Removal of hydrogen is oxidation. So oxidation by the loss of hydrogen. We can label it. The third definition. The third definition or third method of identification of oxidation and reduction in any reaction with respect to electron transfer. Oxidation occur by the loss of electron and reduction is gain of electron. Remembering these definition is essential and easily done using this convenient acronym OILRIG, oil rig. Oxidation is loss, reduction is gain. For electron, we can use this word oxidation is loss and reduction is gain. Gaining of electron is reduction and loss of electron is oxidation. For example, the equation below shows an obvious example of oxygen transfer in a simple redox reaction. Redox reaction is the combination of RED for reduction and OX for oxidation. So this is a combination of reduction and oxidation. Example, CuO plus Mg. Cupric oxide, CuO is cupric oxide plus magnesium having zero charge because atom and molecule have no charge. Collectively, CuO has no charge, but itself copper has 2 positive charge. And magnesium alone has no charge, so it is in atomic form 0 charge. Cu also have no charge, 0 charge. And MgO collectively has no charge, but magnesium is 2 positive because oxygen is 2 negative. Both charges cancel each other, so that's why it is MgO. But itself magnesium has 2 positive in MgO, not in Mg. In Mg it is 0. So 0 change into 2 positive, that is charge increases, and charge increases in oxidation, so magnesium loses 2 electron while cupric oxide gains 2 electron and become Cu0. Another topic, rules for assigning oxidation state. How can we say this like CuO, cupric oxide, Cu has 2 positive charge. How can we know? So there are some rules. The oxidation state OS of an element correspond to the number of electron that an atom loses, gains or appears to use when joining with other atom in the compound. In determining the oxidation state of atom, there are 7 guidelines to follow. I have said that atom and molecule have no charge. So the oxidation state of an individual atom is 0. That is Mg alone is 0. Cu alone is 0 in the previous explanation. So Individual atom has no charge. Number 2. The total oxidation state of all atoms in a neutral species is 0. And in an ion equals to the ion charge. If CuO and MgO in the previous explanation collectively has no charge, 0 charge. But in ionic form, if the charge is written like Mg2 positive is written, if it is written. But in the previous example, Mg alone, so it is 0. If Mg2 positive is written, then 2 oxidation state of Mg. Group 1 element have an oxidation state of 1. 1A group member like sodium, potassium, rubidium, cesium, lithium all have 1 positive charge, so oxidation state 1 positive. Group 2, beryllium, barium, calcium, they are 2 positive, having 2 charge because they are in group 2A, so they have 2 positive. The oxidation of fluorine is -1 in compound like HF. H is positive 1, so fluorine is also -1. Number 5 rule. Hydrogen generally has an oxidation state of +1 in the compound. Like HCl, H is positive 1. Number 6. Oxygen generally has an oxidation state of -2 in a compound. Usually, like CuO, copper is 2 positive and oxygen is 2 negative. MgO, magnesium is 2 positive and oxygen is 2 negative. So usually they have oxygen as 2 negative. In binary metal compound, binary means two metal um, like lithium oxide, sodium oxide, binary. They are binary. So group 17 element have an oxidation of state of -1. This is actually group 7A. Like fluorine has -1 charge. Why? Because it is in group 7. So 8 minus 7 is -1. So fluorine have -1 charge. And you can say group 7 or group 17 are both are same. Group 16 and 6A are the same. So oxygen is in group 6A. So it has 2 negative because total are 18. So 18 minus 16 -2. Group 15 elements have -3. Then determine the oxidation state of each element in the following reaction. Number 1. Fe plus O2. Yes, Fe has no charge, 0 charge. And O2 also have no charge because in molecule it has no charge. Atom and molecule have no charge. Iron is atomic form and oxygen is molecular form, so both have no charge, 0 charge. But Fe2O3, Fe has 3 positive, and while uh, this is in cross form, so 3 is the charge of actually iron and 2 is the charge of oxygen. So this is the oxidation state. Number B, Fe2 positive. Fe2 positive, how much oxidation state? That is 2 positive. Number C, Ag, solid, means no charge, 0 charge. H2S collectively has no charge, but sulfur is in group 6, so or 16, then it has charge 2 negative. So this 2 actually from sulfur So it is 2 negative and hydrogen is H1 positive. After the reaction, silver sulfide is formed. Silver is 1 positive and sulfur is 2 negative. So this 2 came from sulfur, while H2 has 0 charge. This is the explanation I have told you. Number 1 for this equation, Fe and O2 are free elements, therefore they each have an oxidation state of 0 according to the rule 1. Group 1A alone has no charge according to the rule. The product has a total oxidation state equal to 0, and the rule following rule number 6. 0 has an oxidation state of -2, which means Fe has an oxidation state of 3 negative positive. B. The oxidation B question is Fe2 positive. So the oxidation state of Fe correspond to its charge. Therefore, oxidation state of iron is 2 positive, because in the question Fe2 positive is written. C. Silver. Silver has an oxidation state 0, while H has an oxidation state of 1 positive according to the rule 5. Sulfur has an oxidation state of -2 according to the I have explained. This is in group 16 or 6A. That's why it is -2, because 8 minus 6, 2. And silver sulfide has an oxidation state of 1 positive for silver. One more method, Na3PO3. If the question, what is the charge on Na? Sodium. No. The question for to find the charge on phosphorus. Okay. So the oxidation state of Na and O. Na is positive 1 and O -2. One oxygen has -2 charge, and there is subscript is 3 is written, so 3 2s are 6, -6, and sodium is 1 positive, so multiply by 3 become +3. So -6 plus 3, the answer is -3. So phosphorus has +3 charge. This is the calculation. For second, H2PO4 -1. The whole species has -1 charge. So hydrogen and oxygen have oxidation number of 1 positive and -2 respectively. Hydrogen is +1 and oxygen is -2. The iron has a charge of -1, so the sum of the oxidation number state must be -1. Okay, I'm explaining. H is 1 positive, so multiply by 2, because 2 is written as subscript for in hydrogen, so 2 ones are 2. So the total hydrogen is 2 positive charge, while oxygen is -2. Multiply by 4 means -8, and then +2. The answer is minus 6. Minus 6. So phosphorus has plus 5. So minus 6 and plus 5, the answer is minus 1. That's why the whole species has minus 1 charge.